I'm Anil Kumar. Welcome to my series on quadratic relations. We'll talk about transformations and consider all these topics mentioned here. Now, transformations of quadratic functions is a very important chapter. We need to understand all these concepts for moving forward in taking up advanced level courses in mathematics, especially calculus. So, I like your complete attention. We may discuss few topics in greater details. So, this video may last for about half an hour. When we say transformation, we look into a huge equation which could be written as y equals to a times x minus h whole square plus k. Now that is a standard equation which you normally see whenever you study transformations. Now let us try to figure out the basic components of this particular transformed function. We'll begin with the parent function, which is always written as y equals to x square, right? So that is the basic parent function. Now topics to be considered are: first, reflection. We could actually multiply this by a coefficient a, so it becomes y equals to a times x square. Reflections are possible if the value of a is less than 0, that is to say negative value, right? In that case, it reflects on x-axis. So this reflection is on x-axis. We'll take up examples and take up multiple choice questions also on this topic. Stretch or compression. Now in this simple equation y equals to a times x square, the value of a could be greater than 1 or between 0 and 1. So let's take the case when a is I'm taking the magnitude. Leave aside the negative part, right? Just the magnitude of a. If it is greater than 1, then we have stretch. And if magnitude of a is less than 1, in that case we are compressing, right? So we compress. So it's like vertically pulling up and down, right? So in our common language, we'll say stretch is like pulling up, right? So pull up. And this is like push down. Now pull up and push down what? So all these are based on y equals to x square graph, which looks like this. So we are talking about this function, correct? Y equals to x square. So when I say pull up, it basically means that all these points, they kind of get stretched, correct? So we get a steeper function. Now this is what is pull up, correct? So this is what is pull up. And if I say push down, it really means that push them down means just bring them down, kind of like this. So something like this will be pushed down. You get an idea, right? So that is what we mean, right? Now, translations means left, right, up or down, right? So when we talk about translations, we could have combinations of moving left or right, or we could do up and down. The factors which affect translations are just shown here. So the value of k, this value of k, will indicate whether you translate up or down, correct? So if k is greater than, I should say positive, so greater than 0, it means up. And if k is less than 0, means down. Correct. So this is that factor. And age is going to tell us about left or right. So if age is greater than 0, that means x minus 3, for example, that means right. And if age is less than 0, that means left. To give you an example of a function which will move left will be x plus 2 whole square. And the one which moves right will be, let's say, x minus 3 whole square. So we say right by 3 units. So I hope you got this, correct? So we got the basics of all this, and then of course we can combine them all. And if we combine, what we get is shown here. Let me highlight this now. Right, so let's get back to this equation. So A gives you a couple of things. It tells you reflection, vertical stretch, and vertical compression, depending on whether A is positive or negative. If it is negative, only then it reflects. And when I say it will reflect, it's kind of like this. Right? This is, for example, for a function which has been compressed. So we can say minus because it is reflect x squared. So that kind of a function will look like this, right? So it has been compressed and reflected. So that's the combination which has happened. Inside the bracket, it is horizontal translation, left or right, correct? Depending on the value of age, as shown here, and k gives you vertical translation, correct? So what you notice here is that the parts which are outside, so these parts corresponds to vertical, and the ones which are inside, which is here, corresponds to horizontal. Does make sense, right? Now, we got the basics. We'll actually take up examples to describe transformations, sketch parabolas, find the image points, and do the reverse calculation. And then we'll take up multiple choice questions based on our learnings. So now let's look into the parent function y equals to x squared in further details. Parent function. Now, whenever we say parent function, we always mean y equals to x squared for a quadratic relation. Does make sense to you? Always. So whenever we have to describe transformation, it is always with respect to y equals to x squared. Right? So now let us understand some key features of this particular parent function y equals to x squared. Now if I graph this function, it will look like what? A parabola which opens up, correct? Let us see how to graph. Let's take this up, how to graph y equals to x squared, and then we will see how to graph other functions which are transformed y equals to x squared. To graph y equals to x squared, take some points for x and calculate y equals to x squared. Good points to take are minus 2, minus 1, 0, 1, and 2. Their squares are 4, 1, 0, 1, and 4. Now, what do you notice here? Let me take another point, 3 and 9 here. Okay, first let's just sketch it. So 0, 0 is right at the origin. Then we move 1 unit here and 1 unit there. So that is 1. Okay, let's mark 1, 2, 3, 4, 5, 6, 7, 8, and somewhere there 9. Okay, so 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. This is always positive, so I'll just concentrate on the upper half. So the first point here is I'm saying, starting with the vertex, 0, 0, the origin, 1, 1, and then 2, 4. Now here, From one step we moved one up, and then next step we are doing 1 to 4. So we moved one up, now we are moving 3 up from here. So we go to 1, 2 and 3, we reach this point which is at 4, right? So this is at 4, this is at 1, correct? And then we move 5 up. So next step we move 5 up. So next step we move 5 up. So 1, 2, 3, 4, 5, and we reach the point which is at 9, correct? So this point will be at 9. So what you see here are these steps 1, 3, 5 and so on. Next is going to be what? Looking into the pattern, it is going to be 7. So with that, we get the right side of the graph, correct? So we get this right side of the graph, which is kind of like this. Okay. Now, we know parabola is symmetric, so it has even symmetry. It is symmetric about y equals to, x equals to 0, the vertical axis, right? So it is symmetric about y-axis, whose equation is x equals to 0, right? This is important to understand. Since it is symmetric, we could get the other points by just reflecting them. You get the idea, right? So by just reflecting them, so the graph could be reflected and then we get our other half. Now that is a strategy which we will normally adopt to sketch a parabola. So the idea here is sketch one part and then reflect on axis of symmetry. Now this is a huge concept. So you have to follow these small steps to really do well in this particular area. Okay, so this is one thing. Second is, what we also understand here are these steps. So we call them steps. And these steps are 1, 3, 5, 7 and so on, right? So I'll use this word steps. And the most important part, of course, is from where to begin, right? So that is very critical. So always begin from where? Vertex. So that is general. Now in our case, y equals to x squared, the vertex is at 0, 0. So we begin from there. Do you see that? But for a transformed function, which is, let me write down the equation again, which is y equals to a times x minus h whole square plus k. The vertex is hk. So you have to begin from here. Now you also see this term a. How does it affect? It is a multiplier to steps. So your steps gets multiplied by a. Do you see that? So for a transformed function, which is given here, when you sketch, the steps are going to be a times. Do you see that part? If a is negative, it will be reflected automatically. It makes sense, right? If a is half or less than 1, it gets vertically compressed. So it really works. So starting from the vertex, which is hk, you could actually sketch the right side. Now what is the axis? Axis is this point, x equals to h. Do you understand? So that vertical line is the axis. Now this is key to understand to sketch any parabola from given transformed quadratic relation. So I hope that's absolutely clear, correct? So you could begin with these points and then sketch. This is one method. Second method we'll talk about is how the points get transformed. So we'll take that up later. But I hope this is absolutely clear. Let's move on. Now let's look into each component of transformations. So we'll talk about reflection on the x-axis. So when will the graph of a quadratic function reflect on x-axis? Whenever you have the equation y equals to a x square and the value of a is less than 0, then it reflects on x-axis. Clear? So there could be many examples. So let's take a few examples. Okay, so let's say one. Let me write down 3 examples for you. Let's take y equals to minus half x square, y equals to minus 2x square, and y equals to 1 minus 3 over 2 x square. Now we have these 3 relations, all are quadratic relations. What do you notice about their graphs? Will they all be reflected on x-axis? This is negative. We know this will be, correct? So if you sketch this particular function here, what should you get? If you sketch this, what should you expect? And if you sketch this, what should you expect? Well, assuming that we'll start with parabola, which is kind of like this. So in all the 3 cases, I'm giving you a parabola to begin with. So this is x squared, okay? So whatever I've sketched here is x squared. Based on this, let us see how to sketch this part. Minus means it gets reflected and half means it gets compressed. So it should be kind of like this. Does it make sense? Correct? Now in this case, this is kind of tricky. Minus is within the bracket, so when you open this up, it will actually look like what? It will be y equals 2. If you open this up, it is going to be y equals to 4 times x squared. So it is not reflected. You get an idea, right? So this particular graph will be vertically stretched, so it will be kind of steeper. So this one is not reflected. Do you understand? Here it is reflected, of course. This is greater, so it is stretched also, right? Because that is negative and moves up, right? So to 1 unit. So if x is 0, it is at 1. So in this particular case, it does get reflected and slightly stretched, and so it is going to look like this. Does it make sense? Correct? So that is how the graph of each is going to be. So what I wanted to really share with you is that if you have this minus within the bracket, here we do not have any horizontal reflection, correct? So remember, even function, right? So this is even. So we do not talk about horizontal reflection. That means on the y-axis. We don't talk about it. So even. So horizontal reflection has no meaning. Because of the symmetry, right? So these 2 parts are same. So if I reflect, it overlaps. It doesn't make any sense. But the important part here is that even function makes it positive, reflects. No reflection, but it vertically stretches. Do you see that part? So that's kind of very, very important to understand. Okay. Now let's move on and take up example with vertical stretch and vertical compression. Now to understand vertical stretch or vertical compression, let me take a few examples. Let's say y equals to minus x squared, let's say. And then we'll have y equals to 3x squared. And we'll take y equals to half x squared. Let's make it minus half x squared. Okay, so we are taking 3 examples to understand the concept. Let me sketch them also. While sketching, I'll describe you. You can actually pause the video, sketch them, and then we'll be together. Now in each case, we'll just sketch y equals to x squared. You know how to sketch it. Vertex at zeros, follow steps 1, 3, 5, 7. Is it okay? Follow steps 1, 3, 5, 7. So I hope that part is clear, right? So we're not getting into those details. We'll see better sketching later on. Now we are doing very rough sketches, only to understand the concept. Perfect. Now here, when I say y equals to minus x squared, the graph reflects kind of like this, right? So in this particular case, there is no change in shape, right? So we have no change in shape. What I'm trying to say is congruent graph. So what really changes is orientation. Now these are very, very critical things to understand. So when we do just minus, that is to say, when absolute value of a is 1, it could be plus or minus 1. In that case, there is no change in shape, right? The graphs are congruent. Only the orientation changes, becomes like facing downwards. So face up or down. That's it. Okay. But when I do 3x squared, then what happens? When I do 3x squared, then the graph stretches, right? So each and every point, 0 remains there, but the other points, they stretches 3 times. So the graph will look like this. So here you can see it pulls up, right? Shape changes. That means it is no more congruent, not congruent. Now, that is important to understand, as in multiple choice questions, we could ask you something like this, where you need this information. Now here, we have this negative thing, so it is going to reflect it and compress it, so it will be wider, as if we have pushed it. So you have been pushing the graph and reflection, correct? So what do you notice in this particular case? You notice that in this particular case, it is pushed down. This is because of the half I'm talking about, correct? Shape changes. Of course, the reflection is because of minus. Remember that, right? Shape changes. Now, reflection is since a is less than 0, right? So I hope the point is clear. So whenever we are doing vertical stretch or vertical compression, in that case, shape changes. This is important, right? So you learn 2 things here. First is shape changes. It becomes stretched or compressed. And when is it compressed and when is it stretched? Well, clear, since we talked about it earlier. It is stretched when the magnitude of A, whatever you multiply x with, is greater than 1. And it's compressed when the magnitude of A is less than 1. We are talking about y equals to ax squared. Does make sense to you now? Okay, so we're talking about always parent function x square, but when it is vertically stretched or compressed, we are looking into this part, the leading coefficient, the coefficient of x square. I hope that is clear, right? So let's move up and take examples on translation now. So horizontal and vertical translation. In this case, let's get back to our basic equation, which was y equals to a times x minus h whole square plus k. Now the components which lead to horizontal and vertical translations are h and k, right? So for horizontal it is h, and for vertical it is k. Right, so these are the two components which affect horizontal and vertical translation. So now let's take a few examples based on this. So let's say y equals to x minus 3 whole square, y equals to x plus 2 whole square minus k, and then we'll take y equals to, let us say, so we are not taking any stretching factor at present, okay? Now let's take y equals to x, okay, let's take another minus with plus combination. Instead of k, I'll write value 5. So let's say this value of k is 4, okay, whatever. So these are a few equations. Let us see how to sketch them. The very first one, okay, we'll begin with simple graph. So first let me draw y equals to x square. Starting point, it is good to see with respect to the main function, the parent function, y equals to x square. So I hope that makes sense, right? Okay. So when I say x minus 3, what really happens? What value will give us 0? So question is, what will give us 0? That is the question. So in this case, x equals to 3, right? So in this case, x equals to 3 will give us 0. You get the idea. So the graph will move horizontally, of course, but now it is moving like this. Is that clear? So what do you say? So 3 units right. Do you see that? That is the translation. Perfect. So we are talking about translations. So it is translated 3 units right, since that 3 gives part of this 0 in the main function. Does make sense to you? Now we'll ask this question always when we are looking into the inner side of our function. Now in this case, minus 2 will give us 0, right? So because of this, the graph will be, let me just sketch here a dotted one. So this is because of x plus 2 whole square. Correct? So let's look into the horizontal translation first. And now, what will give you 0? 1 will give you 0. So this will get translated to position which is at 1. Does it make sense, right? So here we get 2 left. And here we get 1 right. Okay, 1 right. Does it make sense to you? So we have analyzed the horizontal translation part. Let's look into the vertical. So here vertical is nothing. It is 0, right? Do you see that? 0. So it is not moving up or down. So no need to write anything. But here it comes down by 4 units. So it comes down by 4 units. So I'm just sketching roughly. So this point here is minus 4. Do you get the idea? Correct? So it is 4 down because of minus 4. Now here it will move up by 5 units, so we could have something like this. So here it is 5 up. So we're talking about translation, vertical translation. Okay, so whenever this happens, what is important to see, that shape will not change. What changes is vertex. Vertex changes. So let's find the coordinates of vertex in each case, right? So let's find the coordinates of vertex in each case. So that is a very critical point. So let's look into the vertex now, which is this point, the final graph point. Do you see that? We're looking at this point now, the vertex. So what is the value? What is the vertex in each case? Let's write down. So let me write down the vertex right here in the center, as I feel this is the most important point after horizontal translation and vertical translation. So here you see it is 3, 0. H and k value. In this case, h is -2, k is -4, the vertex is -2, -4. Do you get it? So in this particular case, it is -2 and -4. Perfect. In the last case, it is 1 and 5. Perfect. So I'm writing here 1 and 5. Big and bold. 1 and 5. It moved up. 1 and 5. This moved down to 4 units. Do you see that? It remained in the same plane. The x-intercept actually moved. Do you see that? So I hope you understand and appreciate how we got all this. Another key thing to understand here is y equals to x squared had one x-intercept. Only one x-intercept. Now, the question for you is number of x-intercepts. Tell me. In this case, it is 1. In this case, we have 2. And in this case, we have none. Why? What you notice is that if the signs are same, if the signs are different, let's begin with this, then we have 2, these signs. But if these signs are same for both, then we have none. Okay? But if we have a 0 for vertical translation, it maintains its one x-intercept. Does it make sense to you? Now these three are very, very important points for most of the multiple choice questions which we are going to work with. And at the end of this unit, I'm going to have a test where these points will be highlighted. So try to get them. I hope that is absolutely clear. From exam point of view, this is a key thing to understand. Okay, so once I do these translations and reflections and all this, you need to identify the vertex, number of x-intercepts, and of course the graph. I hope that makes sense. So let's move on and see combination of all this once again. So I hope you are learning and enjoying this journey of understanding transformations of quadratic relations. Now here is the test question for you, right? So I like you to take this as a test. Combination of all the transformations have been given to you, and the equation is y equals to minus half x minus 3 whole square plus 2. You need to describe the transformation and then sketch the graph of the parabola. Correct? So let's begin by describing the transformations first. So let's write down the transformations. I would like you to pause the video, solve this question, and then look into my suggestions. Now there is an order to be maintained, right? So it has to be in a particular order. Normally we say order of operation, right? So what I follow is basically from left to right. So my order is normally from left to right. So that is the order. So move from left to right. So it'll be simpler, correct? Let me rewrite this equation as y equals to minus half, 0.5 as minus 5, x minus 3 whole square plus 2. So moving from left to right, first thing which you encounter is the minus itself. What will that indicate? This minus indicates the reflection on the x-axis. Correct? The next point is half. Half is less than 1, and that means it is vertically compressed by, we say factor of, because it gets multiplied, half, right? Then we move inside the bracket minus 3. It means what? It is horizontal. You are inside the bracket. Translation 3 units. Which side? What makes it 0? So you know x equals to 3 makes it 0, and this is also called the axis. Now it is on the right side, correct? So on a graph, x equals to 3 will be the axis. So let me sketch this axis here to show you the significance of this point. Is that clear? It is on the right of origin. Do you see that? So 3 units right. I hope that will help you to always get it right. Now the last is 2. So that is vertical translation by 2 units up. Now once you know this horizontal and vertical translation, you also know it opens down, right? Reflection means opens down. So let me write here some key features. When I say reflected on x-axis means opens down. Perfect. Since we have these opposite sign, we expect 2x intercepts, okay? Fine. So we have vertex at, so we'll say vertex is these 2 points, x coordinate 3, y 2, and it opens down, right? So 3 and 2 on the axis, it opens down. Does it make sense? So that is your, so the graph opens down, the vertex is 3, 2. So x value of 3, y value of 2, so that becomes the vertex, correct? So the vertex is at 3, 2. Now, we got all the transformations. Let us see how to sketch the graph. So now we will sketch graph. The steps being followed are, basically you should follow 3 steps. First, I can write here. First step is identify vertex, which is in our case 3, 2. And the second step is to get the steps right. Now in our case, minus half of 1, 3, 5, 7. Those are the steps, correct? So let's check the points now. Axis of symmetry shown to you as x equals to 3. Vertex is right there, opening downwards. When you move 1 unit to the left, you have to move half down. Minus means half, minus means down, down half, 1 half, right? So the point will be right there. Next step, you have to do 1.5 down. So next step will be there. And then you have to go 2.5, half of 5. So 1, 2.5. You see that. So you get this part of the curve on the left side, which is kind of like this. Does it make sense to you? Now you know from the symmetry, these points will be reflected on the axis itself. Correct? So you could reflect this kind of like this and go down. Does it make sense to you? That is how you're going to sketch the parabola from the given equation. I hope that makes sense. Perfect. So let me remind you, only two steps: vertex, identify vertex, and then the steps calculation, follow 1/2, and third is which is reflected, right? So maintain symmetry. Third set is get the other leg, right? Symmetry. Correct? So you do one leg and symmetrically the other one. That will give you the most efficient way of sketching parabolas. I hope that makes sense. Now let's take up other test questions. So this was your first test question. Let me write down one here. Now here is the second question for you. Let me write the second question for you. You need to write the equation from the graph of the parabola. You can actually pause the video, answer the question, and then look into my suggestions. The equation will be of the form of y equals to a x minus h whole square plus k. How do you identify these points? First, vertex. So that is the vertex for you, right? So the values are what? So the values for vertex right there are x value of -1 and the y value of -2. So you get h and k value, correct? You only want to find what a is. So what you get here is y equals to a times x. 1 unit left means -1 minus minus makes it positive, plus, this is k, -2, -2. So that will be minus, right? So let me rewrite this as a times x plus 1 whole square minus 2. This is because of the vertex, which is at -1, -2. So this is because of the vertex. Now we need to find the value of a, which is related with steps, correct? So let's count these steps now. So first part was to identify the vertex. The second part is to check steps. Now if I use 1 unit right, I go up how much? I go up by half. Next time I go up by 1.5. So that clearly shows that these steps are positive, going upwards. It is 1, 3, 5, 7, but half is getting multiplied. So a equals to half. Does it make sense to you? So do you get the equation? Yes, you do. You get your equation as y equals to half x plus 1 whole square minus 2. Perfect. So simple. So it should not really take more than a minute to get the equation from such a graph. Okay? I hope that makes sense. Let's move on and take the third test question for you. This one is kind of tricky. I'd like you to pause the video, read the question properly, and then answer. Transformed image points to original points. So it's reverse calculation. Quadratic function y equals to x squared is transformed to y equals to minus 1.5 x minus 4 whole square plus 5. If the points 6 minus 1 lie on the graph of transformed function, this one, find its corresponding image on the original graph of y equals to x squared. I'd like you to pause the video, answer this, and then look into my suggestions. Okay? Take it as a real test question, and you might just get one of this kind. Okay, so let's see how to do it. We are given the equation y equals to minus Now 1.5 is kind of 3 over 2. You can write decimals also, it doesn't matter. And then we have x minus 4 whole square plus 5. Now let's learn about change in points. So the original function, if I have points x0, y0 on the original function, in that case, they get transformed. The x value is 4 units to the right, so we get this point will add 4. As far as the y value is concerned, it gets multiplied by minus 3 over 2 to the original y value, and then you add 5. So that is the transformation. Do you understand that part, right? So it is very important to understand how the points get transformed. We call this image point, right? Now, what are we given here? We are given 6 minus 1 on this side. So we are given this side as 6 minus 1. Do you understand? What we need to find is what is x0 and y0 on the original function. So now you get it. You can now pause the video and answer. This is how we will do it. Let's equate the equation, which is original point plus 4 is 6. So the x coordinate value is 6 minus 4, which is 2. Perfect. On the right side, we have the point is minus, let me draw a line here. Okay. So we calculate this x value, got the answer. X coordinate is 2. For the y, minus 3 over 2 of original point plus 5 is given to us as minus 1. So let's solve for it. Take 5 on this side. So minus 3 over 2 of original point is minus 1 minus 5, which is minus 6. So y0, original point, is minus 6 times minus 2 over 3. Well, that gives you this as plus 4. It makes sense, right? So the original value is x0, y0 is what? Is 2, 4. Correct? That is how we are going to answer this. I hope that's absolutely clear. Perfect. So you need to do reverse calculation to get the points on y equals to x squared from the transformed function. Let's move on and take up some multiple choice questions now. Here is your last question, multiple choice question based on what we have learned. So question number 1 in multiple choices, which of the following parabola is congruent to y equals to x squared? 4 choices are given to you. And question number 2 is, what is true about the graph of y equals to minus 2, x minus 3 whole square minus 4? 4 choices are given to you. You can pause the video, answer, and then look into my suggestions. Now, in the very first question, when we say, which of the following parabola is congruent, that really means no stretch or compression. That is important. Is it okay? So only translations we are looking for. So which one has only translations? Of course, the very first one has only translations, right? 3 up, 1 right. Here we have the stretch factors, so these are not correct answers. Got it? Question number 2. What is true about this graph? Now, it has even symmetry? No. Since you translate left or right, that is not correct. Vertex is at minus 3, minus 4? No. It is at 3 minus 4, not minus 3. 3 minus 4. Minimum value is minus 4. This is negative, so basically this graph opens downwards, right? So it opens downwards, so it has maximum, not minimum. Got it? It has no x-intercepts. Well, that is just the right answer because vertex is at y value of minus 4 and it opens down. Do you see that? So what you notice here is same sign. These two. Then we have no x-intercept. So that's a key, and it makes sense, correct? Your graph, if you'll sketch, it is at 3 minus 4, right? So let's say something like this, right? It's going downwards. From the vertex visits negative y value and going down. Does it make sense to you? So no x-intercept. So I hope that's a good place to conclude. We have learned a lot in this series. Now we know we can start with y equals to x squared, the parent function, apply all the transformations which we have learned, which include vertical stretch and compression, and translations could be horizontal or vertical. I hope you enjoyed the journey. If you really like and appreciate my videos, you can always put some likes. Thanks for watching and all the best.